Hello, and welcome to the user manual for the electronics workstation bench for the Terrible 2 Incorporation. You are currently watching the English video. If any other language is needed, hit the email down below and shoot us an email. We can produce you a video for any other language. In this video, we'll go off from initial boot, setting up the workbench itself, and then using the different variations of features we have: the square wave, sine wave, DC reference, voltmeter, ohmmeter, and frequency read. So let's start with initial boot. Once you order your electronic workstation, you'll receive a DC power supply. As you can see down here, here's where you connect your DC power supply. So let's go ahead and start setting this up. Connect your DC power supply. And as you can see, we have a regular lighting connection. So connect to a plug. But wait, before we connect everything, just set it aside. We have more stuff to connect. Open down here this hatch. Here you would find another connection, which is needed to a lighting plug. And also a set of alligator clamps. These alligator clamps are 5 alligator clamps that we need to connect to these terminals right here. 2 for voltmeter, 2 for ohmmeter, and 1 for frequency read. Just connect accordingly. A set of different colors are going to be sent to you. You can set them up as any color you want. There's no necessary order or anything. Just connect them. Before we start connecting anything to live power itself, I want to go over some warnings we like to provide. Warning number 1, do not unplug / plug into the device while it's under power. So this could lead to shock or initial fire, so don't connect anything to the light before you haven't collected these alligator bites. Another, do not touch the 5 volts and 3.3 volts or ground terminals while the device is under power. So below here, we have our breadboard. Don't connect anything directly to the breadboard. As a user, everything you need is up here. Another, do not charge or pull on the device wiring. As you see, these are very fragile. We don't recommend pulling or tearing any of it. It could lead to potential shock to yourself. Do not input any voltages to a voltmeter that are over 4 volts. While our voltmeter is only capable to reach 4 volt voltage read, we don't recommend inputting anything higher because we don't know what the cause could be led to. And another thing, exposure to any of these devices in the state of California could lead to cancer. Okay, now that we have said all those warnings, we are ready to do an initial boot. So grab your 2 plugs, the one for the screen itself and the other one for the DC supply, and just connect them directly straight to the lighting plug. So initial boots look like this. On the LCD screen, we can see all those black squares. We're just realizing that it's going to start booting up. Just give it a second to load. Okay, now that we're all suited up, we can see the LCD screen is finally on. Average boot time is 30 to 40 seconds. So while the workbench boots up, just chill out and relax. Before we dive anything deeper into the device, let's just go over some hardware stuff we have in front of us. This is our rotary encoder. The rotary encoder helps us move through the various modes in the display and in the software. So right now we're off to main, mode select, LCD color, and as you can see, we go back and forth and it changes to the different steps. Here we have our ground. This is common ground for all devices that are going to be used. In this plug, we have square wave output, sine wave output, DC reference. These 2 alligator clips are voltmeter. These 2 alligator clips, ohmmeter, and our frequency read. So now that we have showed you all the hardware what we have right here, let's go ahead and start by using one of the different modes. So we use a rotary encoder, we go through the directory, and we go to mode select. To input mode select, we click down. Now we're in mode select. We can do function generator, ohmmeter, voltmeter, DC reference, and measure frequency, and back. The back will send you back to the main loop, in which we're back to where we started off. Let's go back to main mode select. Now, further on in the video, here are the timestamps. You can skip around. We're going to go through square wave, sine wave, DC reference, voltmeter, ohmmeter, and frequency rate. In each clip, we'll go over how it's used and how you can change the different amplitude and frequency for each. And at the very end of that clip, we'll have a real life application. So down below are the timestamps. You can skip around if you don't want to see a certain part. Just skip around and see the different parts. All right, we'll get all started with the different uses. Now for the example for the square wave, we'll start off from the very beginning. So we're going to start off from the main menu, scroll down to mode select, click mode select. In this example, we're going out in the field and Bob needs a square wave for an electronic station he's going to test. So he wants a square wave that is plus or minus 5 volts and a 50% duty cycle, but he wants it at a very specific frequency of 3,500 hertz. So this could be a wonderful application of our square wave output. So now that we're in mode select, select function gen. And in function gen, we select type. We're going to use a square wave. So we select square by clicking. When we select the square, let's verify that. And we go back. And now that we selected the square, we go down to frequency and we give it the frequency value, which is 3,500 hertz. So we select input frequency, click down, and we select it, scroll down until we get to 3,500. That's 4,500. So keep on scrolling. Would you get there? Just select it. Frequency is 3,500. We set the value for the constraint there. Now we just got to turn on the output. So we go back from frequency, function gen, where we scroll down to output. And in output, we select it. Output on. So we just set this node as on, the square wave. So we should be reading 3,500 hertz out of that. And as you can see, 3,500 hertz within a plus or minus 50 hertz range. So that's how you use the square wave. Now for the example for the square wave, we'll start off from the very beginning. So we're going to start off from the main menu, scroll down to mode select, click mode select. In this example, we're going out in the field and Bob needs a square wave for an electronic station he's going to test. So he wants a square wave that is plus or minus 5 volts and a 50% duty cycle, but he wants it at a very specific frequency of 3,500 hertz. So this could be a wonderful application of our square wave output. So now that we're in mode select, select function gen. And in function gen, we select type. We're going to use a square wave. So we select square by clicking. When we select the square, let's verify that. And we go back. And now that we selected the square, we go down to frequency and we give it the frequency value, which is 3,500 hertz. So we select input frequency, click down, and we select it, scroll down until we get to 3,500. That's 4,500. So keep on scrolling. Would you get there? Just select it. Frequency is 3,500. We set the value for the constraint there. Now we just got to turn on the output. So we go back from frequency, function gen, where we scroll down to output. And in output, we select it. Output on. So we just set this node as on, the square wave. So we should be reading 3,500 hertz out of that. And as you can see, 3,500 hertz within a plus or minus 50 hertz range. So that's how you use the square wave. Second feature in our electronics workbench is the sine wave output. Similar to the past feature we just showed, square wave, we start off in the very beginning in the main menu. We scroll down to mode select, click on mode select, In multi-select, first feature provided is function gen, which is function generator. We click down. Now we're in function gen. And first feature in function gen is type. We click down on type. Here we have type sine. We have two options in the type column, either sine or square. Or in this case, we're going sine wave, so we click down on sine. We have selected sine, and it's verified by the screen. Now we go down and see back. We click on back. Now we're back to the function generator menu. Here, since we're using a sine wave, we're allowed to change various features such as frequency and amplitude. So here, let's change the frequency in our case. So input frequency, we click down on input frequency. So for our input frequency, we have values from the minimum being 1,000 and the maximum being 10,000. Let's just say in this example, we're gonna output a sine wave of 3,800 hertz. So 3,800 hertz, we click down, and frequency is 3,800. We're setting that value. Now that we set frequency, we go down and go back. Now let's change our amplitude. Back in function gen menu, we have type, frequency, and amplitude. Now let's change the amplitude for the sine wave. So and we click down on input amplitude. So let's just say we need a sine wave of 3,800 hertz at 2 volts. So similar to the square wave, our input values for our sine wave range from 1 volt to 5 volts. And the sine wave itself is a positive sine wave. So all values are going to be positive with no negative voltage. So in this case, we're just going to choose a sine wave of 3,800 hertz and 2 volt amplitude. So we're just going to click down on this to select it. Amplitude is 2 volts. Now that we selected amplitude, frequency, and our type, which is sine wave, we go back. And in function generate, we go all the way down and click output. And now we select output on. And our output is on. So we are outputting right now a sine wave from this terminal that is 3,800 hertz and 2 volts amplitude. That's how we have the feature for the for the sine wave. And as you can see at the very end, it read us frequency that we were outputting. Now we're going to go on to an example of how the sine wave output could be implied in the real world field. Now for the sine wave example. So similar to the square wave example, let's just start off straight from the main menu. So Bob's out in the field and he's testing out his electronic circuit, and for some reason he just needs a sine wave to be inputted to that circuit. So let's start off from the beginning using our electronic workstation. So in the main menu, we go down and we click on mode select. In mode select, first terminal right there is function generator. We're going to need that. So type, we click on type. First one, sine. We need a sine wave, so we select sine and selected sine wave. So we've set sine as what we need. Now we go down, hit back. Now in the sine wave, Tom needs a sine wave with frequency 4,000 hertz and an amplitude of 2.25 volts. So let's set the frequency. Click on frequency, input frequency. So he needs a frequency of 4,000. So let's go down and choose 4,000. So just use the rotary encoder, go down, select 4,000. So we're setting the value to be 4,000 for that sine wave. So we already inputted frequency. Now we go back. Now we got to input amplitude. So we scroll down in function gen directory. Oh, skipped it twice. Right there, amplitude. We select amplitude and select input amplitude. Click down. So select the value. What did we say again? He needs a 2.75 volts. Just reread the prompt. So 2.75 volts. So we're going to go down, select the amplitude to be 2.75. So amplitude is 2.75 now. So now we have set amplitude and the frequency for it. So now let's go back and output it. So we go to output and set output as on. So now it should be outputting a sine wave of 4,000 hertz with a 2.75 volt amplitude. So we're reading the frequency being outputted right now. So we are currently reading 4,031 hertz being outputted from the sine wave output within a range of point plus or minus 50 hertz. But just to verify, let's throw it on this oscilloscope. So probe right here, ground right here. And as you can see on the oscilloscope image up above, we are within parameters of what we set. So that's good. And you see our accuracy is relatively good. So that's a good application for Bob to throw this signal within his electronics circuit. So that's an example of what you can do with a sine wave. Once you're done using the sine wave, we go back here and we scroll down to off function. We click on off function and we turn off the function signal being sticking out. So now that's how you use the sine wave, and that's a real application of what Bob could have used it for. All right, now for the example for the DC reference, Bob is working on a simple RLC circuit, and he needs a 3-volt reference for his circuit. So let's start off from the main menu and show Bob how to do that. So from main, we go down to mode select. From mode select, we're in mode select directory right now. We go down until we see DC reference. When we see DC reference, we click on it. From here, voltage value in, we click on that. So we said Bob needed a 3-volt DC reference. We go up to 3 volts and we set that value as 3 volts. Once we have set the 3 volts value that we want to do, we scroll down to output, we select output and set the output as on. So we are currently kicking out 3 volts from DC reference right now. So let's just to verify, let's throw it on a multimeter. One probe negative onto the negative side, the other probe positive to the positive side. And as you can see by the image above, we are relatively throwing out 3 volts with a slight decimal point, but it's very accurate, which is really nice, which is perfect for Bob to throw that on his circuit just to verify what he needs. Once we are done using the DC reference, we go down on the output and off DC. We're just setting the DC to be off, which once we click on it, it just boots and it's automatically off, which is great. So that's an example of how Bob can use our electronic workstation for his use onto it. Feature number 4, our voltmeter. So from the very beginning, we'll start off with the main menu. We go down and select mode select. Click down to select mode select. Now in mode select, we have function generator, ohmmeter, voltmeter. In this case, we're going to use our voltmeter. So select down and click voltmeter. In voltmeter, we can either have an external source, which are going to be connected to these 2 alligator clips. In this case, the left one being the positive and the right one being the negative terminal of that DC reference. Or we can read an internal reference. So similar to the last clip in which we used a DC reference, here we can read that internal reference from that DC reference just to verify we're in that position. So we're going to start off with that one since we already used the DC reference in the last clip. If you want to go back and see in the last clip, we are currently outputting a 3-volt reference from there. So just to verify, we go down an internal reference and we select it. Three volts. And you see, it's read the 3 volts that we had. Now, let's go back. But now, say it's going to take you all the way back to mode select, but we're going to go down again to voltmeter. And now we're going to use an external source. So right now, we currently have nothing connected, as you see, and it's in a red 0 volts. But say we had something connected to the positive terminal, which is this one, the left side, and a negative terminal, it would read the output within a quarter resolution. And you'll see that in the next clip in which we make a real-life application of this voltmeter. So just hold on tight, and you'll see the preciseness of this feature. All right, for example, for the voltmeter, we're going to start off from the very beginning, from the main menu. We scroll down To mode select mode select. Now we choose through the various features until we find voltmeter. Once we find voltmeter, we click down and selecting it. First scenario, we're going to check an external source. So we're going to connect a DC source and verify the voltage that's being outputted. So in this case, we're just going to connect positive to positive. The negative already have it connected. So we click down external and it should output us the value, which is 2 volts. Now we're going to check for internal voltage. We use the DC reference and we can set it to the value we want it to. So when you click internal, send you to that stereo, you give it the value you want. So in this case, we're going to set the value by clicking down, and now we should be outputting that value down the DC reference. But first, we have to turn it on. So we go down to output, we set output as on, and we should be outputting that output from the DC reference. So that's the voltmeter. All right, feature number 5, our ohm meter. So similar to all the other features, let's start off from the very beginning, the main menu. We scroll down and see mode select. Let's click on mode select. Here in mode select, we start off with function generator. So we proceed down, ohm meter, second option in our mode select. We select ohm meter. Right now it's already reading, so it's very direct. But in this case, we'll be using these 2 alligator clips. This one being the positive and being the negative. But we all know in resistors, there's no polarity. So either or, just connect your resistor in these 2. So we connect the resistor. In this case, we're not going to connect anything yet. We'll see the real application in the next clip. And we just click display reading. You know, the resistance is greater than 1200. In this case, we are capped by resistance over 1200. So just know that, be aware of that. And now that's how you use the ohm meter. In the next clip, we'll see a real application in which we connect the real resistor. We'll connect a series of various resistors. I'll verify the resistance value with a multimeter, and then we'll connect it to our electronic workstation. We'll verify how precise it is. Now for the ohm meter example. So we're going to start from the main menu. We scroll down, click on mode select. In mode select, we scroll down until we find ohm meter. In this scenario, Bob found a random resistor throughout the lab. He just wants to check the value. So using the 2 alligator clips we have designated for the ohm meter, in this case yellow and white, we connect this random resistor we found in the hallway. So Bob just connects it. One terminal, one side, and the other side, and then we just click down. Display reading, and as you can see, it's an 1,000 ohm resistor. We're within plus or minus 25 ohms, so it should be an 1,000 ohm resistor. Now for frequency read, which would be this pin right here, we're going to start off from the main menu. So we go down, mode select, click mode select, and we scroll down and mode select until we find frequency read. So measure frequency. We select measure frequency. In measure frequency, we have 2 sources. We can either do an external source. So say we're trying to measure something on a circuit itself, we connect this pin to it and ground to the ground pin, and we can find the frequency being derived out of there, or we could do an internal source. In this case, an internal source will find the frequency either from the sine wave or square wave that is being outputted. So in this example, let's just use internal. Internal, we click internal, takes us up to the function gen directory. Here in type, we select type, and we can go either sine or square. So let's just use sine in this case. So we're selected a sine wave. Now that we've selected the sine wave, we can go down, click back. In a sine wave, we have 2 things we could change, frequency and amplitude. In this case, we're just going to change frequency, so we're just doing frequency read. So input frequency, let's do 5,350. Selected the frequency. Now we scroll down back in frequency directory, and we go all the way down to output to set the output as on. So an output on. So now we should be exporting a sine wave out of here, but now the reading frequency is reading the frequency there. So as you can see, frequency is 0 hertz. Now for frequency read, we're going to start from the very beginning in the main menu. Go down, mode select. Once we're in mode select, we're going to scroll down until we see measure frequency. That's going to be our frequency read. So once we found it, click on it. Frequency is going to be read from the white terminal at the very right. So in this case, we're going to connect it to a function generator in which we output a 7K hertz sine wave, and we're just going to verify that it's giving us the same amount. So we're going to connect red, positive to the frequency read, and our common ground to the common ground. Then we click down on external, and it should output the frequency read. It gives it within 10 to 15 seconds. You just give it a minute, and it should output right about now. So you see 7,036 hertz within plus or minus 50 range of hertz. So it's very accurate. So once we're done with that, that's the external source. But we also can do an internal. So that same frequency read is attached to our sine wave. So click on there. You set it as a sine wave, and we go down. Now we're going to go back, and we're going to change the frequency. So in the function gen, we click on frequency. We're going to input the frequency. In this case, we're just going to go with the first value, 5,000 hertz. Select 5,000, input frequency is 5,000. So we go back. And now we're just going to set that output as on so we can verify it. So output and output as on. So according to what our parameters are, we're reading the frequency that's being outputted from that sine wave output right now. We just set it as 5,000 hertz. And it is currently outputting 5,000, a little bit over 5,000 hertz. All right, now for bonus features. We all love us bonus features. We have a little Easter egg thrown into that electronic workstation for us. So for this Easter egg, we got to start off in the main menu. Off in the main, we start off with our first directory, off main. We go down, mode select, and go down LCD color. That's our bonus feature. We can change the different color of this LCD randomized. So we select LCD color. And LCD color change. Just click on that. And bam, as you can see, we just changed the color to little green. Click it on again, and it randomized the color another time. Now we're like in a dark brown color. Click on it again. Now we're blue. So that's one of the bonus features we like to include in our electronic workstation. So you can change the colors to very different colors. Randomized too, so, gives it a little exciting feature because you don't know what color you're gonna have next. Now that you have seen all the various features and applications of this electronic workstation bench, we would love to hear back from our customers. So shoot an email down to the email down below and give us your feedback. We would love to receive feedback and develop further developments in this project. So don't hesitate to shoot us an email. We'll try to respond as soon as possible. If any more help is needed for customer support, don't hesitate to reach out to us. We'll be grateful to help you. We don't recommend you to work on the hardware internally itself, as warranty will be voided if you decide to maneuver into that endeavors. So just don't hesitate to reach out for us. We'll gladly help you out with anything. Thank you for your time. And don't forget to like and subscribe.